Good morning, afternoon, or evening to everyone joining us today. My name is Jessica Taylor, and I'm here at the Canadian Centre for Evidence-Based Conservation in Ottawa, Canada. If this is the first time you're joining us, welcome to the Environmental Evidence Summit series. As you may know, we created this series to replace the cancelled in-person Environmental Evidence Summit that was supposed to be here in Ottawa this past June. This has allowed us to reach hundreds of more people than we originally planned and is giving us a way to connect with you over the next year through monthly sessions. So with that, I'd like to welcome Samantha Cheng and Stephen Alexander, who will be chairs for this session today.
Thanks, Jess. Hi, everyone. So welcome to this month's session for the webinar. This will be focused on mobilizing knowledge for evidence-based approaches in the Anthropocene. So let me just this for 1 second. So we'll be bringing different perspectives from across the research and the decision-making space in environmental and development sectors to talk about the challenges and the opportunities for mobilizing knowledge. So we are your co-organizers, along with Vivian Nguyen from Carleton University, who could not join us today. My name is Sam Cheng. I'm a conservation scientist at the Center for Biodiversity and Conservation at the American Museum of Natural History in New York, and I'm the coordinator of the Collaboration for Environmental Evidence's US-based center.
And I'm Steve Alexander, the science advisor based in the Environment and Biodiversity Science Branch of Fisheries and Oceans Canada. In today's session, we will give a brief overview of this topic, followed by our three presenters, Beth Nybor, Beckett Sterner, and Jeff Hansen. Now, following these talks, we will be hosting a panel discussion with our presenters and moderators on experiences and opportunities for knowledge mobilization in the face of today's environmental and developmental challenges. For the audience, please send any questions for our speakers through the questions function on the sidebar, and we will have our speakers address them after the talks. We'll be moving from one talk through to the third talk, and then respond to questions as we have our panel discussion. If you have any logistic or technical issues, please direct them to Jess Taylor in the chat function.
So we've heard a lot in this overall webinar series about evidence synthesis and how important they are for harnessing this growing body of knowledge to inform policy and practice across a whole range of different decisions and users. And in particular, the challenges that we face currently in the Anthropocene are characterized by their inherent complexity and the significant degree of both uncertainty and of risk in the scale and the scope of these challenges that are occurring within and across complex and interlinked social and natural systems, decisions, and involve multiple actors.
Now, accordingly, understanding how to mobilize this knowledge for multiple actors is of paramount importance. In recent years, there have been a significant shift away from thinking about mobilizing knowledge using a loading dock model where information, relevant or not, is simply released into the wild and may never actually be picked up and used. However, challenges in mobilizing knowledge for and from evidence syntheses for diverse actors, decision contexts, and knowledge types remain. Now, there are many approaches and tools such as data portals, reports, and visualizations for facilitating knowledge uptake. However, there is little understanding of their impact, much less how they can be effectively designed and deployed in order to maximize evidence for utility and decision-making.
So when we try and unpack this knowledge action gap and try and examine
Sam, sorry, can I just jump in?
Yeah.
We're skipping half of your slides.
Oh.
Yeah. I thought maybe it was just me. Thank you for jumping in, Jess.
Keeping you guys all on your toes. All right, let's me. All right, let's try this. Can you see all of them now?
Yes.
Perfect. Okay, so there's this whole other side of this, the knowledge action gap. Apparently, we were only showing you action. So we want to try. We want to try and unpack this knowledge action gap and start to examine what Vivian Nguyen, one of our co-organizers, has called it the knowledge mediation sphere. it's really critical if you want to do this to try and apply evidence-based approaches to take on some of these complex challenges. So in this first session, our panelists are going to be sharing perspectives on knowledge mobilization of evidence syntheses as a multi-actor process within different types of decision-making contexts, and share some of the challenges and the opportunities that they've experienced through different case studies in environmental institutions, in digital knowledge commons, and in conservation and development. So before we begin, just a quick reminder to everyone to please send your questions through the question function for our speakers, and I promise that other future presentations you'll see the whole thing.
All right, thank you so much, Sam. And as we switch to our first presenter and getting the screen up and sharing, I'd like to introduce our first speaker, Dr. Beth Nibor. Beth is a postdoctoral researcher with Dr. Steve Cook at Carleton University and is jointly appointed with the Biology Department and the Canadian Centre for Evidence-Based Conservation. Beth's research background is in aquatic conservation and fisheries sustainability, and her postdoctoral research focuses on amplifying the impact of environmental evidence for policy and practice. Over to you, Beth. Let you take it away.
Okay, thank you so much, Steve. Can everyone see my slide? Okay, great. Just give me 1 second here. Okay. Oh, sorry. Okay, so thank you so much for the introduction, Stephen, and thanks everyone for being here today. I'm going to be talking today about some work that I'm doing in collaboration with the Canadian Centre for Evidence-Based Conservation that looks at the perspectives of Canadian practitioners and decision makers on the use of evidence syntheses within their organizations. Oh, my slide's not advancing, sorry. There we go. Okay, so the concept and value of evidence-informed decision-making has grown in environmental arenas over the last couple of decades. So in this field, there's an increasing awareness that the evidence emerging from environmental research is not used often enough or effectively enough to inform policy and practice. And this is true despite the fact that there is widespread agreement amongst players that overcoming the knowledge action gap between science and practice is essential to promote the best possible conservation of biodiversity and natural resource management. And so there's several well-documented reasons for why the knowledge action gap exists, but by far the most commonly cited barrier to evidence-informed decision-making is the lack of effective knowledge exchange among scientists and decision makers. So on the one hand, scientists might feel frustrated that their information isn't used, or at a loss as to what the precise information is that is needed by the policymakers. But from the perspective of the decision makers, scientific evidence might be difficult to access, overly complex, or contradictory among studies. And it can be incredibly daunting for a decision maker wading through all of these details to try to draw conclusions that are meaningful. So evidence syntheses are a key tool that can be used to overcome these hurdles and to potentially help to bridge that knowledge action gap. And as we heard from Samantha and Stephen, evidence syntheses refers to the process of drawing together information from diverse sources and disciplines in a cohesive manner to inform decisions on a given issue. And evidence syntheses can take a variety of formats, and I have several examples of the most common ones listed here. I don't have time to describe each one of them, but they're detailed in this Cook et al. Paper that I've cited below. And just briefly, evidence syntheses can range from these very empirically driven analyses like systematic reviews, meta-analyses, etc., that follow a standardized methodology to answer specific problems. And so while these are highly rigorous, they're very time-consuming to complete and resource-intensive. On the other hand, at the other end of the spectrum, you have methods like vote counting or conceptual models narrative reviews. These are potentially less rigorous and less repeatable, but they're much faster to produce, and they're very useful when there are strict time constraints. And so the list that you see represented here is going to come into play in discussing the results of the study that I'm going to talk about today. So they're color-coded with darker tones representing the more rigorous and time-consuming types of data syntheses, going into lighter tones representing the more rapid but perhaps less reliable types. And I just want to mention here too that all of these forms of evidence syntheses serve important purposes. So this isn't necessarily supposed to be a best to worst. This is just one way to categorize and conceptualize the different syntheses. So for a little bit of insight into the Canadian context, Canada is a large country. It's the second largest country in the world landmass-wise, with a broad diversity of ecosystems. Canada is also very rich in natural resources, which contribute substantially to employment and about 17% to the national GDP. And Canada's Indigenous peoples have traditional and constitutional rights to their natural resources. And there are also highly engaged user groups across the country, such as fishers, foresters, and other nature lovers. And so all of these factors highlight the complexity that comes along with environmental management in Canada. At the federal level, there are 4 environmentally focused organizations, including Environment Climate Change Canada, Fisheries and Oceans Canada, Natural Resources Canada, and Parks Canada. And then you have provincial and territorial and municipal governments, Indigenous governments, and environmental non-governmental organizations that all work to create and inform policy decisions. And while each of these organizations has capacity for evidence-informed decision-making and have used evidence syntheses or produced them to varying degrees, the situation is far from perfect, and there have been many circumstances where decisions are made that might go against evidence. As scientists have pushed back on this, mechanisms are being put into place to ensure the use of evidence in decision-making, and more evidence syntheses are being produced. However, it's still unclear from the perspective of a policymaker how evidence syntheses are perceived, how well they're understood, and how frequently they're actually used by environmental practitioners and decision makers. So today I'm going to present the results of a study that investigated the perceptions and attitudes of Canadians that have extensive experience at the science policy interface on the use of evidence syntheses in environmental decision making. So along with the Canadian Centre for Evidence-Based Conservation, we've also collaborated with folks from several of the federal government organizations mentioned before, as well as some NGOs. And the results I'm presenting today come from a manuscript being headed by Dr. Laura Thomas-Walters, who is a postdoctoral fellow at the University of Stirling in the UK. In the summer of 2019, one of our core team members, Carleton master's student John Francis Lane, interviewed 84 environmental experts across different sectors in Canada. Our interviews included folks from provincial, territorial, and federal government organizations, including the 4 organizations mentioned earlier, and those working for high-profile NGOs with an interest in advising policy. So these were fairly broad interviews. The overall goal was to provide direction for scientists, practitioners, funders, and stakeholders to amplify the impacts of environmental research on policy and practice in Canada. For this study, we're focusing on 2 questions from the interview. The first presented a list of different possible forms of evidence, of which evidence synthesis was just one, and then asked which were the top forms of evidence used to inform policy decisions. And then the second question presented a list of different forms of evidence syntheses. And so now this is the same list that I showed you a few slides back. We asked participants to select the top 3 types of evidence syntheses that they have confidence in, so the ones they trust the most, and then the top 3 that they actually use on a day-to-day basis. We also asked people to reflect on their choices and to describe why they chose the way they did. So in general, the interviewees viewed evidence syntheses positively and indicated enthusiasm for their use in decision-making processes. And this is summed up by this quote from a participant from Environment Climate Change Canada that says, "Sure, I can do the job of trying to read 1,000 studies and summarizing them, but I would much prefer to have someone who I can trust from a good school who writes clearly and who is reflecting on a lifetime of experience." Then looking at the results of the first question, so here we have the different forms of evidence on the x-axis and the percent of all respondents that selected those forms on the y. We've shown that over 38% of the respondents selected evidence synthesis as one of the primary forms of evidence used making policy decisions, coming in 3rd after peer-reviewed and primary non-peer-reviewed literature. The qualitative analysis of participants revealed a common theme for this choice. So many participants viewed scientific results as more trustworthy if multiple studies come to the same conclusion, and this is something that can be demonstrated by a synthesis. And finally, most respondents indicated that evidence syntheses are very convenient to help keep up on the broad research context and consensus. So moving on to the second question, where we asked participants to select the top 3 forms of evidence synthesis. In this slide, we're showing responses to the types of synthesis that most people are confident in. So in this figure, again, we have the different forms of evidence synthesis on the x-axis and the top 3 selected in % on the y, and then the same color gradation that I mentioned earlier. So you can see that in general, the more rigorous and empirical the synthesis, the more confident people feel in using them. So most respondents trusted meta-analyses and systematic reviews, with rapid reviews and vote counting ranked lower. And then we can switch to looking at what people actually use, and we see a slightly different pattern. So although the rigorous ones are still at the top, now we can see that some of the most rapidly produced types of syntheses have also ranked quite high, so things like narrative reviews and conceptual models. So in looking at these two side by side, we can see some inconsistency between what people have confidence in and what's actually used. So while higher proportions of people suggested high confidence in these first two, a lower proportion actually use them. And then the opposite can be said for the 4 methodologies that rank lower in terms of rigor and repeatability. The qualitative analysis suggests that this inconsistency between confidence and use is due to the opportunistic use of evidence syntheses. So decision makers reported being constrained by what's available to them. So for example, this quote from a participant from Fisheries and Oceans Canada says, "The ones that I actually use, it depends on what's available. I think it's based on availability, not based on confidence. So given that, it's probably more often narrative reviews." So this was particularly true for the more trusted options, which are extremely resource intensive and require high levels of analytical expertise, and therefore not always available. For time sensitive or emerging issues, the more rapid forms are highly valuable and thus used more often. So our research suggests that in Canada, syntheses are viewed as an incredibly useful tool that can save time and reduce bias compared to searching the primary literature for one-by-one studies. And if available, high quality and relevant evidence syntheses will be used and embraced. Oh, sorry, I skipped ahead there. Okay, so these points are exemplified by this quote from a participant from Environment Climate Change Canada that says, "At the end of the day, it's actually people in my position at the science policy interface where it's like I have to go in and I have 8 slides and maybe 5 minutes to communicate someone's 10-year academic findings. And so synthesis maps, figures, images, I use those more than anything else." So the question really remains, how do we get better at increasing the number of rigorous evidence syntheses out there, making sure that they're relevant and timely for current environmental issues, and ensuring that they're widely available and shared or communicated through appropriate channels? Possible ways forward include continued and increased funding to dedicated evidence synthesis centers and ensuring good communications between those centers and end users, building in-house capacity within various organizations to conduct evidence syntheses, and using horizon scanning techniques and working with end users to publish priorities for evidence syntheses. So with that, I'd like to acknowledge the contributions of all of the co-authors on this work, as well as the funders that supported this project, our 84 interview participants, and then the collaborating institutions. And thank you very much for your attention.
Thank you so much, Beth, for that fantastic presentation and kicking off this afternoon's session. Our next speaker is Dr. Beckett Sterner, who is an assistant professor in the School of Life Sciences at Arizona State University and the associate director of the Biodiversity Knowledge Integration Center there. His research focuses on discovering what knowledge people need to work together while differing in fundamental ways, and his current projects center on alternatives to globally centralized data aggregation. Take it away, Beckett.
Thank you. I'm not seeing my slide coming up, even though it should be shared. Is anyone else? Are you able to see it? Can you start it over again, and I'll talk while we set the video or we get the slides going. So hi everyone, thank you, and it's great to be here. This talk is a collaboration with Steve Elliott, who's also at ASU. And I swear to God, we practiced this 3 times and it worked. And of course, now it doesn't. And I've never seen this before. So I'm gonna let other folks think about it and keep talking, and maybe we can figure out what's going on, because I don't know what. I guess I can try starting it over again. Huh. Well, that's frustrating. There we go. Okay, no clue why. The talk today is going to be a little bit programmatic, and I'm really interested to connect with folks and sort of talk about what we've been working on here and think about where we might go with collaborations. So we're going to start off and talk about our kind of starting point in biodiversity data portals and how they're engaged in a kind of synthesis around integration and aggregation of data. We're going to then look at how we can generalize and begin to synthesize results on sort of a meta level of all of these different pooled resources about knowledge that are even extend beyond conservation and are being studied for what works and what doesn't. And so we're going to position data portals as knowledge commons here and talk through how that brings a useful framework to understanding their structure and key variables, and then how that allows us to connect up lots of exciting work going on in other domains such as open source software. All right, so this is probably familiar to most folks, right? But we're in a context here of wanting to inform decision-making, for example, about halting biodiversity loss, and really needing to have predictive models as that basis, but then having a very challenging problem of putting together lots of data distributed over many different sources and also of many different types into training input, right, for the predictive models. And so ideally, this would look like a feedback loop where it's not just the scientists pushing data out into the world, like the loading dock model that Sam was talking about. It's also a backwards process of learning what matters in decision making, you know, what's useful, what you have confidence in, and how that can inform the design of models and data. Our focus on biodiversity data portals is really going to be at the bottom here of this layer cake, but we're thinking in this broader context. And one of the likely familiar concepts here that's been around for a while now is this notion of data portals and even individual data records being boundary objects that can move across locations. They can be reinterpreted to inform local decisions, local contexts, and so they're plastic or customizable that way. But they also have a kind of stability or robustness that allows them to travel meaningfully from where they were collected for one purpose to another context that that collector never imagined. And this original paper by Starr and Griesmer was talking about museum specimens being collected in California. But of course, now the cutting edge is about the digitizing those museum specimens and also digital, born digital images like in iNaturalist. And that takes us to the Museum 2.0 of these data portals. And we just want to emphasize quickly here that these are more than just websites, in that they have quite a lot going on behind the scenes in terms of processes for storing and aggregating data, formal social organizations with role types and different responsibilities and rights, and then also governance rules and that do things like enforce metadata standards. And there are enough portals now that we have this really quite rich and complex ecosystem. I'm not going to go into the details here, but the idea here is that you have data in individual collections like museums or specific institutions. Those can be published under standards like the Darwin Core that make them reusable across contexts, at least to some extent. And then you have this layering of portals that do different things. So one form of synthesis is to focus on curating a view of the data, for example, with a particular taxonomy or a particular set of metadata categories for a region or for a group. And then on the top level, you have then a different kind of synthesis where you're trying to put all of the data together into one coherent data set. And these have different roles here and different challenges, but it's important to think about how they are all supposed to fit together. And boundary objects here, I think this is sort of commonly recognized now, only get us so far. Yeah, so data portal is a boundary object. Great, nearly everything can be treated as a boundary object. Everything is able to move, negotiate transfer of understanding or information and so forth. Which ones really matter and how do they matter? In the context of the original paper, it wasn't just the specimen that was a boundary object, it was the museum, it was California. There were lots of other things that were key to enlisting support from funders and collaborators and farmers and other collectors that made the whole study of California biodiversity possible. So how can we push forward what boundary objects can do for us as an idea, right, to address this challenge? We need some additional theory here, I think, that will help us derive more informative predictions about which objects matter and how. And then we need to put our heads together to figure out how new methods can help us test these hypotheses empirically and drive our general understanding of knowledge synthesis forward. So what I want to pick up on here is that it might feel like what's going on in conservation is kind of specific and focused and really pushing forward in that arena, but there's also lots of parallel things going on and things that might look very unrelated on the first glance. And so we're going to use knowledge commons to help tie these things together. And I'm thinking here, for example, of projects in open source software, governmental data portals, scientific data portals, and peer information sharing projects like Wikipedia. And the framework we're going to drive for knowledge commons will help us harmonize and integrate results across studies in these different domains. So what is a knowledge commons? People often use the word commons in a kind of metaphorical or loose way. There is actually a very established and mature tradition of talking about commons in a theoretically precise way. The notion of knowledge commons is one flavor within that literature. And it's particularly talking about the institutionalized community governance of the sharing and in many cases creation of information, knowledge, data, etc. And focused on pooled resources of knowledge that are institutionalized in terms of access, editing, and regulation in a particular way. And so just to be clear, when we're talking about a commons, we're not actually talking about the lake here as a shared natural resource or a database per se as a shared data resource. We're talking about the way that the lake is run, the way that it's governed collectively in terms of how you can access it, how you can use it, what you can do to it, etc. Same thing for the database. So when we're talking about a commons, we're talking about a form of community management or governance rather than the object itself. That's just meant to help clarify and will be relevant for the theory. Okay, so what can we then do with thinking of biodiversity data portals and these other forms of open resources as commons? And here, what's helpful and sort of by design is the work of Eleanor Ostrom in really pioneering the notion of commons also came with this framework called institutional analysis and development. And what it is a sort of very basic set of terms and factors that need to be paid attention to in any given context that are put into place to help ensure that if one person does a study of governance of lakes and another person does a study of governance of a database, for example, they have enough in common that one could still think of both of those as examples of commons, that you could look at how different governance approaches, for example, work or don't across the broader category. And so some key features here in the background conditions are characteristics of the resource, the metadata standards, the data records, how they're produced, attributes of the community, who's involved, who are the stakeholders, who's contributing, and what are the norms that they follow, which are not necessarily the rules written down on paper, right, or in the law. What actually happens in the ground is important. And then also, given this background, what goes on, and so to try and figure out different types of situations that actors can be in when people edit data, for example, or when people import data sets from other data portals, can be different types of action situations. And when you put the background conditions, the types of situations together, you can then watch the empirical patterns of interactions that emerge and how those feed back to change the underlying factors that are driving them. And you can then think about whether this is going well or going poorly according to different criteria. So this is meant to be a set of things to keep in mind and that we need to track and understand in order to help studies be comparable. And what we want to add to that, and this is sort of the key step to starting to link different studies together, is a more formal model of types of rights and responsibilities and how those can define different organizational roles. And so, for example, here we've got the rows are different types of rights that someone can have with respect to data records in a database, which can include adding or editing the records. Also standard setting, right? So what does it take to add a record to a database? It has to meet certain metadata standards. And depending on which rights, shown by the blue boxes here, a person has, they can be treated as having one or more different roles with respect to that database's governance. And we've got the sort of written out formal definitions here. And in fact, what we argue is that these roles are not specific to a database, although some of the details are. You can walk them back and find quite comparable things in other contexts, such as open source software. And so Nadia Eghbal has this wonderful book that just came out this year, where she did an in-depth study of many different projects on GitHub, the open source software platform. And she has a parallel notion of maintainers, contributors, and users as what I was just showing you, but focused on GitHub code editing. And she goes a step further and generalizes different types of projects, such as large groups that are split into modules that work quasi-independently, like for Linux, particular clubs that have a highly specialized user group that also tends to be contributors, and so forth, that help make sense of not just what's the underlying governance, but why are we seeing certain patterns in whether we have a lot of contributors or have a lot of users. And we can also do things using these notions of maintainers, contributors, and users to begin to study project variability. And so this is a paper studying different modules in Linux and the amount of the number of maintainers who are responsible for 80% of some aspect of the project, like 80% of the files or 80% of the code edits that are committed. And so what you can see here is across these different modules, you have different proportions of maintainers who are doing the bulk of the work. And so it's about the distribution of workload and what do you gain by adding another person as a maintainer. And so I think these results can usefully inform what we do with data portals and not just open source projects when we can understand the underlying framework. Okay, and so I think I'm out of time. So I'm just gonna wrap up by saying, I think this is a fruitful direction forward for how knowledge commons can help us generalize and harmonize empirical results of what works in evidence synthesis and other open knowledge projects. And I think there are a lot of neat insights here that can come out of the typologies and studies of project variability. All right, thank you very much.
Fantastic. Thank you so much. Fantastic, and really great to see this this spectrum of the way we can start to kind of grapple with this this gap and this interface in when it comes to mobilizing evidence synthesis. Now, our third and final speaker is Dr. Jeff Hansen, who is a postdoctoral researcher working at Carleton University. Now, his research focuses on developing cost-effective plans to conserve biodiversity. Jeff is joining us from Australia, so we're actually going to play a video that seems to be the best quality, and then he'll be joining us for the panel discussion live virtually. So I'll turn it over to start the recording.
Hi, my name is Jeff. I'm here to talk to you today about optimally allocating resources for gathering evidence and managing biodiversity. Before we get into it, I'd first like to thank my co-authors, Jenny, Yadine, Caitlin, Emma, and Joe. Okay, so today we're in the middle of a global biodiversity crisis. Over the last few decades, a great many species have gone extinct, and we really want to do something to stop this. How do we get here, where we ideally halt and reverse these declines to improve the current biodiversity status? As ecologists, we like to think that data should play some role in achieving a positive biodiversity outcome. But how exactly do we connect the dots? Well, we take our data, or ecological surveys, places where people have gone and looked for species, and we use that data to synthesize information using evidence synthesis or statistical models. Once we have this information, we can formulate a plan or prioritization using our explicit conservation objectives and constraints, such as the total amount of money you could spend on establishing protected areas. Then when this plan is implemented, we would achieve our biodiversity outcome. But how can we achieve an even better outcome? Well, one way is we could collect more data. If we allocate funds towards collecting more data, we would have better synthesis and better statistical models, which would lead to a better management plan and in turn lead to a better conservation outcome. However, if we have limited resources, which we usually do in conservation, then if we allocate a lot of resources towards collecting data, we'll have much better models, much better predictions of where species are, but we'll have much less funding available to implement management actions. And this will severely constrain our plan and limit the scope of the conservation actions we could implement. This would mean that we would then have a worse biodiversity outcome. So my collaborators and I were interested in understanding how we could design ecological surveys to maximize conservation outcomes. To achieve this, we looked at a case study in Middlesex County of Canada. In this county, we identified 142 different places that could potentially be acquired for protected area establishment. We then obtained cost data to estimate the costs of establishing protected areas in these places. We then obtained data for 9 imperiled plant species in the region. And then we identified 90 places from the original 142 that could potentially be surveyed to improve this existing data set. But how do we go about choosing which places to survey? Well, ecologists have come up with a lot of different approaches for doing this. Let's take a look at them. So a really common approach is spreading your sampling effort out across the geographic space of the study area. So we generated 90 different survey schemes from 1 to the total number of places we could survey based on this approach. So 1, and here's 46, and here's 90. Another common approach is surveying places that have different environmental conditions. This is based on the idea that different species should inhabit different environmental conditions. So if you sample different environmental conditions, you will find out where different species occur. As we can see, if we look at this, if we compare survey schemes that both selected 46 places, these two approaches gave us slightly different survey schemes. Another common approach is selecting places where you think species are most likely to occur. So we fit a bunch of species distribution models to predict the probability of species occurring in different places based on our existing data. And then we generated a survey scheme that selected places where most species were likely to occur. We also generated another survey scheme by selecting places where these species distribution models had really poor predictions and they had a hard time figuring out where species really occurred or not. And finally, another common approach is selecting places with low management costs, based on the idea that if places have low management costs, if species do actually occur there, then it gives you an easy win-win. To evaluate all these survey schemes, we conducted a value of information analysis. This analysis involved looking at 4 different budgets of $7 million, $12 million, $19 million, and $26 million. To start off this analysis, we calculated the performance of conservation plans based on current information. So on the y-axis here, we have the expected number of imperiled species that are adequately conserved by a conservation plan based on a given data set. So these gray lines show us the performance of conservation plans based on existing data, and we can see that we get a higher expected number of species that are conserved when we have more funds, going from 2.5 to nearly 6. So this tells us that when we have more budget, we might expect to achieve a better biodiversity outcome. That's not really that innovative, but it's important to verify these obvious things before we try more interesting things. So let's look at a single survey scheme approach, spreading your sampling effort out across the geographic space of your study area. So remember that we generated 90 different survey schemes based on this approach. So here we have a line that's actually composed of 90 little dots that we've all connected together with a line. So over here, this tells us the performance of the survey scheme that involves selecting one place based on geographic coverage. And over here, this tells us the performance of a survey scheme that involves selecting all 90 places. And when we connect the dots for all 90 of these different schemes, we can see there's a negative relationship, meaning that if we allocated a lot of funds towards surveying places under a restricted budget of $7 million, we actually would expect to achieve a worse biodiversity outcome than if we just used our existing data set. But as we increased our total budget from $7 million to $12 million to 19 to 26, we can see this slope changes from a negative relationship to a positive relationship, meaning that when we have a greater total budget, spending funds on surveying more places actually gives you a greater biodiversity outcome. So this tells us that allocating funds for gathering additional evidence can mean better outcomes for biodiversity. But it can also mean that allocating funds for gathering additional evidence can mean worse outcomes as well. Now let's look at all the other approaches for generating survey schemes. So each of these different lines represents a different approach for generating a survey scheme. We can see that if we compare the performance of survey schemes across different panels, they generally increase as we increase our total budget. And this tells us that these existing survey scheme approaches don't massively change the fundamental constraints of our system. If we have a limited budget available to us, then there's only so well we can do. But if we compare different survey schemes within each of these panels, we can see, especially under larger budgets, different survey schemes can lead to a very different conservation outcome. For instance, if we selected places based on species richness for surveys, so surveying places where we think species already occur, we actually get a lot of information that isn't very useful. We can see that even though we're surveying lots of different places as we go along this orange line, the performance of our conservation outcome is actually staying pretty constant. So this additional information is effectively useless. But if we look at the red line, representing when you select places based on their management cost, we can see that there's actually an increase from 5 to about nearly 7 and to nearly 7.5. So this tells us this approach for generating survey schemes is actually pretty effective, or at least much more effective than the other approaches we looked at. But this result may not generalize to other systems, because in our case, we had very large differences in land acquisition costs between different places. And we also had a lot of existing survey data too. So for instance, selecting places based on species richness or prior uncertainty may not actually have as much of an influence as you might expect. So critically, all of these conventional approaches though can lead to a worse biodiversity outcome. You can't just use one of these approaches and guarantee that you will improve your conservation outcome. So to rectify this, we came up with a new method. We directly maximized return on investment to try and develop an optimized survey scheme. So we can see here, this black dotted line shows us the performance of this optimized survey scheme. And we can see it's higher than the gray line. So under all of these budgets, collecting additional data could improve the conservation outcome. But critically, this optimized survey scheme didn't involve allocating all of the available funds for surveying sites. Under a limited budget of $7 million, it only allocated $1.5 million for surveying sites, and the remainder of those funds were earmarked for management actions. as we increase our total budget to 26 million, we can see that the amount of money allocated towards surveying different places increases, suggesting that at least under these range of budgets, that allocating more funds to surveying places makes more sense when you have a greater budget. But that result probably won't hold if we had a really, really high budget. And if you want to know why, ask me later. So what we can see here is maximizing return on investment is the best method for gathering evidence. And this is because it actually considers the objectives and constraints that underpin conservation plans and their success. So the take-home messages here are: conventional approaches for designing survey schemes can impede conservation outcomes. In fact, you might be better off using existing evidence instead of allocating funds to gather more evidence, depending on your situation. But critically, maximizing return on investment can help you gather evidence that leads to better conservation outcomes. So in conclusion, more evidence is not always better. So don't just always insist on getting more data. Think critically about how getting more data or more evidence would actually improve or change, or maybe even worsen your conservation outcome. Thanks for listening to me. You can contact me at these places.
Thank you, Jess. And thank you everyone for your very, very interesting presentations. I think they're all super thought-provoking. So we're going to transition now to our panel discussion with our speakers, and they'll be joined by our moderator, Dr. Stephen Alexander. I do encourage folks, if you have any questions, please do pop them in the chat. But I want to start you all off with sort of a question thinking about some of the themes that we brought up in this webinar. So in your area of work, we're all working with different evidence users, evidence producers, and evidence synthesizers. Where do you see there are major disconnects in between the needs of folks in these different communities? And where do you think, or why do you think that these exist? So I'd like to start actually with Beth. You talked a lot about some of these challenges perhaps about the ability of knowledge to meet the needs of decisions and whether or not it's due to the ability to locate and connect to those and to different communities who have this knowledge. So I'd like to get your thoughts on that to start.
Yeah, sure. Yeah, so there are clearly lots of different circumstances where someone might really need or want to use evidence synthesis, and that it's just not available for the appropriate spatial or temporal scale or the precise location required. But even in cases where evidence synthesis does exist, the degree to which those approaches have the desired outcomes to actually change policy, that's much less well understood. So like in our interviews, people were very positive about the use of evidence syntheses, and clearly that's helping them. Those are people who are at the science policy interface. It's useful for them to try to communicate. But we know from the literature that often when there's a politically controversial decision to be made, science is often swept to the side. So it's really, I think, where a big disconnect is really trying to convince that person who's actually making the final decision, who has to take 15 different considerations where science is just one of them, or where the research evidence is just one of them, that evidence from environmental research is really key. So I think one of the sort of big things that we have to think about and where the disconnect lies is trying to think about how can we get lots of different forms of evidence synthesis into one of these reviews, lots of different types of evidence into a synthesis, and make a good case for weighting the science more heavily than maybe some of the other options. So that is where I would see there being like a little bit of more work to be done in terms of making those connections.
Thanks. I think this has a lot of sort of connections with what some of our other speakers have talked about in terms of how do we optimize the allocation of resources when we may be limited in terms of time to be able to optimally get everything that we would like to consider for the decisions. Jeff, do you have thoughts on this matter, given your work in optimizing resource allocation for evidence gathering?
Yeah, I think for me, like a lot of, so I guess I'm not really an expert on evidence synthesis. So I guess first up, if I say something stupid, then don't feel obliged to behold to it, and please call me out. So I guess with a lot of the work that I do, I rely extensively on data repositories and data portals. So I've used genetic data from Dryad and GenBank, and just species distribution data from GBIF, Atlas of Living Strata Red List. And I think like one of the major disconnects with some of these databases or portals is they don't provide spatially explicit information. So for instance, GBIF does a wonderful job of providing this spatially explicit information that you can then use to generate plans for places. But things like NCBI GenBank, which has a ton of genetic data, is almost entirely useless for conservation because a lot of it doesn't tell us where the data was collected, and so we can't do anything with it because conservation is inherently a spatial problem. So yeah, does that answer your question? Or
Yeah, and I think I'd like to actually turn this over to Beckett to speak a bit more about this, because I think this relates a lot to the sort of the norms and the governance around these types of data sharing platforms.
Yeah, and I'd say one of the lessons that I've been exploring the last year or two is the trade-off between hoping that there's a general purpose solution for everyone and investing in centralized infrastructure that drives that forward versus betting that you're going to need a lot of locally customized solutions on different scales. So maybe some global, but a lot of mid-scale and small scale. And that would lead you to invest more in infrastructure that coordinates across decentralized solutions rather than tries to put everything in one place. And in that context, I think, there might be a role for funding portals that put in the effort to solve the gap of spatial data for a part of GenBank, but GenBank may not see that as its mission on the biomedical side. And so how do we support people who want to go in and add pieces of the puzzle, even if it's not a global solution, I think is an interesting challenge.
Yeah, certainly. And, certainly I think a lot of the decisions that folks on this call who are watching, on this webinar who are watching and working across different sectors is trying to balance all the various needs between not just a single decision and a single evidence user, but multiple different users who all have different perspectives within a decision. Steve, would you like to talk about that a bit?
Sure, absolutely. I think that was really what struck me when I was thinking about, as Beth was talking, giving her presentation, thinking about the uptake and use of different kinds of evidence synthesis products, thinking about Jeff kind of reflecting on kind of the challenges or barriers with some of these portals, and Beckett talking about these portals as these boundary objects. I was coming to the same place as you, is that you have this constellation of actors that are acting in different ways, and so in some cases the use for them, the users who are leveraging evidence synthesis are not just decision makers. They could also be other researchers and practitioners. And so it's trying to imagine the various permutations or applications in which it will be leveraged. And so you have those who start, developing a particular portal or platform or interface with certain objectives in mind. And this is what you noted, Beckett, in thinking about the biomedical field. But now all of a sudden you have conservation biologists and ecologists saying, oh, wait, wow, we could leverage this in a new way, but you don't have spatially explicit data. And so, I mean, that also presents this optimization challenge or question about, how you invest money or resources to be able to serve those different challenges. And also thinking about the different roles that someone can be both a contributor and a user at the same time versus those who are just using the information, trying to pull from it. And so in what ways, in what formats do they want the data or the metadata, or do they want it in a nice tied up package? And, seeing this really interesting question and connection between Jeff, this optimization challenge, and, what you were talking about, Beth, in terms of the use and application of different kinds of products. and that there may be instances where decisions need to be made on a fairly tight timeline. And when you have certain approaches or methods that are time and resource intensive, you might not have that luxury. So what are the other ones to use? What might be other characteristics? Does it come down to, you know, the team that's behind it and the trust that decision makers have in certain programs or approaches or research teams or individuals? Think about, you know, these other aspects that you might, you know, it got me thinking about what's the optimization challenge when you think about some of the other characteristics of research teams and groups that are performing evidence synthesis, or are there, you know, weight placed on certain data portals, you know, like this is a trusted source versus this is, or, you know, we know the quality of the data that's going into this. We know it's well curated. We know it's updated regularly. You know, starting to think about those characteristics, kind of taking some of those ideas from what Jeff was talking about and applying them to these other contexts, really struck me as an interesting direction and insight we could glean.
Thanks, Steve. This, you know, I think this brings up some of the points that the audience has also introduced, which is, you know, when we're working with decisions that are inherently complex, they come with different levels of risk, different levels of uncertainty for different actors. You know, maybe I'll pose this as a closing question, so we'll give you each 30 seconds to address. You know, where do you think, from your perspective, whether you're talking about data portals, you're talking about evidence synthesizers, evidence users, where do you think the key trade-off area to consider for your work is? I guess I'll go in a circle from where I'm looking at. Beth, you want to start?
Yeah, so you're asking, can you say the question again? Sorry, Sam.
Sure. When we're thinking about the sort of the complexity of all these decisions, weighing risk and uncertainty of the decision itself, the reliability and the rigor of the synthesis, the type of evidence, the type of use, where in your perspective, from your experience, do you think one of the key trade-off areas is that you have to consider?
Right. Yeah. I mean, I think that because I'm coming at it from such a general perspective, I guess, in the research that I presented, and people who are facing a huge multiplicity of problems and very diverse set of problems, that I think, you know, it's always just important to start the process by understanding very clearly the decision-making context that you're in. And so that means communicating really well with the people who you are trying to produce. Say you're a evidence synthesis creator, you're someone who's making an evidence synthesis. You know, you have to like know what your end user needs exactly, what their timeline is. Are they in a large management or a narrow management area? What's the level of certainty that's required from their analysis? Like all these things that we've kind of been touching on. And in my presentation, I referenced this paper by Carly Cook, published in 2017 in Conservation Biology, and she published this really beautiful decision tree where you can kind of follow the different choices down, and you can, you know, based on timeline, level of certainty, etc., you can pick what is the best one for your circumstances. Another thing that was really interesting that came out of this work is that often, even for these really technical syntheses, even though they are sort of drawing together all these studies, they can still be quite technical and difficult to understand. So it's important that those are also communicated. So we need to be able to mobilize the findings from evidence syntheses and communicate them really clearly to the people who actually have to use them and present them, which is why I really like that quote that I used at the end that was like, you know, I need to be able to understand this fast, and so I need sort of a figure. So there's kind of this idea of using a lot of different kinds of evidence synthesis sometimes. Sorry, 30 seconds, I'll stop talking there.
That's fine. Beckett?
I think one of the most interesting trade-offs, other than scale, like I mentioned, is the hidden cost to more contributors. And so one of the studies in open source software found that more contributors who were not highly experienced actually just led to more management challenges for the maintainers. And so they're just responding to largely not helpful requests for information and is this right? instead of people who actually know how to solve it asking to add it to the code. So more contributors may not always be a good thing. And I think that's really interesting.
And Jeff, we'll close with you.
Yeah, so I think one of the major, well, there's lots of challenges. One particular challenge is trying to present conservation plans or prioritizations, or I guess policy recommendations, in a way that's kind of interactive. So decision support tools, I think, can play a big role in that. But also emphasizing the option value in those kinds of tools or systems. So showing that, you know, you might have a near optimal or optimal plan, but there might be a lot of other kind of thing, other alternatives where you can customize the plan or prioritization in a way that achieves a very similar outcome, but it more aligns with a whole range of other objectives that haven't really been articulated or communicated well, or maybe that have just been realized. So I think exploring the range of possible solutions and providing a way for people to do that effectively is a big trade-off and challenge in my work, if that makes sense. Cool.
Sorry, I'm muted. Thanks everyone. This was a really intriguing panel discussion and a set of presentations. So I just want everyone to give a round of digital applause for our speakers, and apologies for running over a tiny bit. You should see here that our next session is going to continue the discussion on this topic, focused on the types of tools and the types of approaches to actually facilitate the exploration, the access, and the use of evidence from Syntheses. This will be on November 23rd at 3 p.m. Eastern. You can register on the EES website, and we look forward to seeing you all then. Thanks again. Oh, thanks everyone.
Well, thanks so much, Sam.
Thank you
Thanks,
all.
everyone.
We're not still broadcasting, right? I'm not like.
Oh, so we're finished now? Cool.
No, I think we're broadcasting.
Oh.
Oh.
Yep, I just want to say thank you. I hope you'll tune in to part 2. Thanks, Sam and Steve. Thanks to Beth, Beckett, and Jeff. And on behalf of the CE and the Canadian Centre for Evidence-Based Conservation, thanks for being with us, dealing with our technology hiccups. And just to let you know that the session for December, plotting a course for strengthening the conservation evidence base, is now open for registration as well. All right, thank you.